Sushmita, start.
Hari Om and Namaste to one and all. Invoking the blessings of Pujya Swami Gurudev, I welcome you all to this very interesting session on Vedic mathematics. Let us begin our session by offering our prayers to the Almighty. I request Ananya to invoke the blessings of the gods. Ananya, please.
Hari Om, everybody. I'm going to start by invoking the blessings of the Lord, and we will start by chanting Om 3 times. Sahana bhavatu sahanau bhunatu sahaviryam karavavahai tejasvinavadhitamastu ma vidvishavahai. Om Shanti Shanti Shanti. Hari Om.
Thank you, Ananya. Well, mathematics as a subject has always scared me from childhood. The additions, subtractions, multiplication and divisions. Oh, well, all of us do remember and we use it in our daily lives, right? I wish someone had taught me about Vedic mathematics in those days, so simplification would have been even more simpler. Vedic mathematics was first introduced to the world by His Holiness Jagat Guru Sri Bharati Krishnatirtha Swamiji, the then Pithadipati of the Govardhana Matha in Puri in 1965. The concept of Vedic mathematics aims to make mathematics easier and interesting, fun and simple, using the sutras found in our scriptures. Today, we are fortunate to hear about the concept of Vedic mathematics and introduction from Gowri Ramachandran ji, who is a renowned expert in Vedic mathematics. I now request Prem Swarup to introduce our esteemed speaker to us. Prem Swarup, please. Prem Swarup, can you hear us? You're on mute.
Yes, Vasini, can you hear me? Hari Om. Am I audible?
Yes, you are Prem Swarup, but turn off your video. Yeah, should be fine so far. Good. If it's there's disturbance, please turn off your video if required.
Yeah, my video.
Turn off your video, please. It's
disable, and can you see me on video?
no, Prem Swarup, there's disturbance. Shall we turn it off? I'll ask Sushmita to do the introduction then. Unless you're able to turn off and do it.
Prem Swarup, can you please turn off your video? And then speak.
Sushmita, do you have the material?
Yeah, am I audible now?
Yeah, better.
Am I audible
Yes,
now?
you're
Go ahead.
Hari Om. I'm facing some issues. I'm not sure.
Prem Swarup, leave it. Someone else take up. Sushmita, please take up, or I'll do it. Shall I do it? Only thing is I have lots of people saying they're not able to join. I'm not sure what's the problem. Vishwajit ji, can you help out the guys in our team? I'm not sure why they're not able to connect.
I also had, it's a meeting in progress here to quit and try again. So
quit and try again. That's what I'll tell them, because lots of people are messaging me saying they're not able to connect.
Hari Om, am I audible now? I had bandwidth issues.
Yeah, but still there is some issue with, we are not able to hear you very well.
No, can you hear me, Anupam?
Yeah. You can go ahead.
Okay. Okay, so I'll just do my introduction part. So before we start off today's session, I would like to introduce you to our speaker, Gowri Ramachandran. She is the Chief Financial Officer for the Institute for Advancement of Vedic Mathematics, a UK-based charity. She is also a partner for Penmetsa and Associates, Vishakhapatnam. Gowri Ramachandran is a fellow chartered accountant. She has a diploma in professional education from Philippines and is also a certified trainer in Vedic mathematics. Her key accomplishments include designing, developing, and conducting workshop series for international audience Kolam, which is an Indian art form, and also mathematics. She has delivered talks on Vedic mathematics and conducted various training programs for different age groups across India, Philippines, and Europe. A lot of notable books and journals have been published by her. Some of her works include Vedic Mathematics Training and Learning Resources, Volume 1, Inspirational Maths from India, fun worksheets on Vedic mathematics for students of grades 3 to 7 for a group of schools in South Africa. She has also chaired the Lilavati contest conducted by Institute for Advancement of Vedic Mathematics as part of the online Vedic Mathematics Conference for 2 consecutive years. Some of her other achievements include a social enterprise fund for women in Philippines, which helped design and develop products using handicrafts and trained women to earn a livelihood. Her artwork featuring Kolam is featured in Natick, Boston, and is displayed as a street art in Natick Cultural Center. She is a member of the Finance Committee of the Board of Trustees of Cebu International School, Philippines, and is also the treasurer for 4 and 2 years respectively. She has led teams in auditing and presented financial statements of various public and private limited companies associated with various chartered accountants across India. These were some of her many technical achievements. Gowri Ramachandran has completed over 75 open water dives in the seas of Southeast Asia. She is a great scuba diver. She is also fond of reading modern fictional books on Indian mythology and history by English authors. She also enjoys sewing, embroidery, needlework during her leisure time. It is a pleasure to have you on this meet on Vedic mathematics, organized by Chinmaya Arpanam. Hari Om.
Thank you, Prem Swarup. That was indeed an amazing introduction, and she, of course, is a multitasker. That's great. Before we move on to the session, I would like to just announce, after the session, there'll be a 10 to 15-minute question and answer session where you can ask any of your queries to Gowri ji. If anyone wants to ask any questions, please put it in the chat box. I will call out the names. You can unmute yourself and then you can directly ask Gowri ji. After you, Gowri ji, please, the session is yours.
Thank you for the very nice introduction. Let me share my screen. How many of you have heard of Vedic mathematics before or know about Vedic mathematics? I would like the session to be interactive. So if you want to share something in the chat box or say something, I'm so glad to listen to it. I think I penned it a little long. If it is too long, we can cut short it anyway, but there's a lot of math that will be going on. If you need, you can have your pens and papers in hand. But we'll try to do it a little mental mathematics initially, and later on you might need a pen and paper. Chat box. Sorry. I would like you to rename yourself so I can interact with you with your names instead of Galaxy or anything else. Short names are fine, but it's nicer to be interacting with names. So have anybody of you did Vedic mathematics for yourself or your children? That's my next question. Anybody wants to? You can write it in the chat box, it's fine.
Hari Om, I am Dayasri, very senior citizen. Just the concept of Vedic mathematics itself appeared to be a new and innovative one. So that's why today I joined. But I think I will be benefited as a senior citizen, not through my children or grandchildren are not at all in this.
Nice to hear that, Jayashree ji. Yes,
Only the-
Vedic mathematics
I am
can also
only
be
the-
used as
so
recreational
I-
mathematics, actually. Yeah.
uh,
Awesome. I understood what my audience is. So before we jump into the topic of Vedic mathematics, I would like to, I know during the introduction, it was said that it was given to us by Bharati Krishna Tirtha Ji Maharaj in 1965. But a little bit more of that, and probably, the term Vedic itself, if you see, or rather when we say, like Jayashree ji said, it's relatively new. I agree, Vedic mathematics is relatively new, but many of us must have heard it as tricks, magic. Many people do it as instant math, memory math, and many of you must have heard it in that way. But believe me, I can even prove it to you that it is not magic. It is an open-minded way of solving a problem, an arithmetic or even algebra or anything in higher mathematics, in a way that a mind will naturally solve it if we haven't taught what we were taught in schools. So having given that description, let's see, many of us know what is Vedas. So let's see why Vedic mathematics, or what is Vedas before going into the actual book of Bharati Krishna Tirtha Ji. Why Vedas? We all know that they are 4 Vedas. The Rig Vedas, Yajur Vedas, Sama Veda, and Atharva Veda. To keep it simple, Rig Veda is like a book of mantras. Yajur Veda talks about rituals and things you have to do in daily life. Sama Veda has chant, mostly in musical notes. And Advancement Veda has everything else, like philosophy or say economics or politics and everything else is in Advancement Veda. But what maths and Vedas, what do you think about it? Where is maths in Vedas? So to answer that question, actually Vedas are a series of hymns or beautiful stanzas, poetry form, and we think we are reciting them. But inside those Vedas, there are a lot of math involved, or arithmetic or geometry involved. If you see Rig Veda, geometry is used in the form of like how to draw the Homokunda or things like that. So Rig Veda has a lot of geometry involved and how to do the rituals. And in fact, the circle or the pi or the value of pi as an approximation, the 22/7, is first appearing in Rig Veda. Samaveda has music, like I said, but maths and music has a different dimension altogether. I'm not going to take it up here. When you come to Yajur Veda has a lot of numbers in it. Numbers to the extent of, I will be showing you a little chant a little later. To the extent of 10 to the power of 18. And that is the biggest number shown in Yajur Veda or recited in Yajur Veda. It's called Prarabdha. And Atharva Veda actually has almost all the mathematical concepts which we are learning now. In fact, Bharati Krishna Tirtha Ji in his book actually said that he is basing his sutras from Atharva Veda. So having known there is math in the Vedas, I would also like to take this opportunity to show you how maths evolved, or the maths we know was already known by our ancients. I know it's like a boasting, but we can always show, or there are a lot of proofs that we only know from our childhood, from our learning, that Indian math, we discovered zero, right? But what is there in that zero? We always credit Aryabhatta or Brahmagupta for discovery of zero, frankly. But like you said, in Yajur Veda, which conservatively dated to 1200 BCE, though there are many claims that it's much older than that, we are not going there. So there is the decimal system neatly said in Yajur Veda in this hymn. I'm not a person with Sanskrit, so I'm not reading it, but what the numbers that are appearing is the base numbers, or the 10 and the 10 to the power of numbers here, to the extent of 10 to the power of minus about 27. So you as you can see, even though we credit zero to a later, where Aryabhatta is 400 N76 CE, or Brahmagupta is 668, like 700 years. But Yajurveda itself has given the power series already 10 to the power of 27 until 10 to the power of 27. And we can see once we are describing this, there is a concept of zero and the power of it here in the Vedas. But what is the evidence or the physical evidence of zero is from India, right? So then there comes this great manuscript called Bakshali manuscript, which was unearthed in British India somewhere in, the current Pakistan, called Bakshali. We don't know the author of this manuscript, but it was written, or it was done on a bark of a tree, and that manuscript contained a lot of hints, and those hints in the form of questions and then solutions to it. And then those problems or solutions did not limit to arithmetic. It had like geometry and equations, quadratic equations, and much more to it, involving business, involving economics and everything, all mathematics problems, and a scientific way of solving those problems in that manuscript. That manuscript is currently in, where, in the Oxford University Museum. But so this manuscript was unearthed in 1800s or 1700s, 1881. But the dating of this manuscript is around 200 BCE to 200 CE. Again, this is a conservative figure because this manuscript was written down by somebody saying that this is not mine, but I'm writing it for somebody, or told by someone, something like that. So in this manuscript, and this manuscript was written in a script which is older than the current Devanagari Sanskrit. It was written in the script called Saraswati, which is a script used in the Kashmir region for Sanskrit before Devanagari came into picture. So you can see how ancient it is. So in this manuscript, when they are solving the problems in the manuscript, they have used zero particularly in the form of a dot. So they were using zero much before what we know currently as, or why India is credited with zero. So there is, we always say discovery of zero rather than, we have found out a zero, or we discovered, because it was already there from a long time. So this manuscript had calculations using zero and place value, and also the knowledge of infinity in the Vedas. I will leave the infinity part for now. We will do it at the end when we have time. But again, not to go to sense, I would like to highlight a few major mathematical theories which we credit to the Western or the European mathematicians, which were actually used by or being used by Indians much before that. For example, Pythagorean theorem. We are not telling Pythagoras because we are not crediting to him. The dating of Pythagoras is around 500 BCE, whereas we can see this in Bodhayana's Sulva Sutras, which is 1500 BCE. Again, if you see Pascal's triangle, which dates Pascal's time period is around 1600 CE. These are all conservative figures or timeline. That it's not like a clear one. But then Pingala in his Neru Prastha had actually given the Pascal's triangle in a way for his Chandra Sastra. And Pingala's timeline was around 300 CE, so which is much before Pascal. And then if you see Fibonacci sequence and the golden ratio, again, it is dated around 1200 CE, but then Pingala in his Chandra Sastra had already discussed Fibonacci sequence. And then much later, Hemachandra in 1150 CE. Till 50 years, even if we credit Hemachandra, again 50 years before, which actually it was credited to. And then last, this is not the least, I've taken very famous mathematical credits. I didn't take everything which we know of, and we can say it happened in India before it happened anywhere else in the world. But when you come to value of pi, Rigveda gave an approximation saying 22/7. but the value of phi using infinite series, much more than 3.14, it goes on to infinity. That is credited to Newton actually in 1600. But Madhava of Sangamagrama, and this is a very famous, school of mathematics, Kerala School of Mathematics actually. He had used the infinite series to calculate the value of phi in 1300, 300 years before Newton. So you see that our scriptures were already, giving all our mathematicians a lot of knowledge which can be, practiced much before it was learned or developed by the Europeans, and from there which we got them back to us. But this is a little bit of hint to tell you that what we are learning is not what we are learning from the Western, but it was already there. Though it seems boastful, but again, if we have proof, why don't we say it out loud? These are the few famous mathematicians and their timelines. I'm not going to go through them, but I just listed them to tell you that, mathematics was an evolved theory of knowledge much before what we started learning it in the current era. So first comes these four mathematicians. The Sulva Sutras are based out of Vedas. So the Bodhayana, Apastamba, Katyayana, and Manava. Their dating is around 1500 CE, and Pingala, then comes Pingala with his Chandra Sastra, and so on and so forth. And if you keep seeing, every 100 years, there is a new mathematician who has come up or who had come up with a great work of mathematics in our country or in our subcontinent, I would like to say. And all the way to, if we credit Srinivasa Ramanujan for all work he has done, then, probably the greatest mathematicians of the current era, we try to say it is Srinivasa Ramanujan. And when we come to this manuscript of Vedic mathematics given by Bharati Krishna Tirthaji, he passed away in 1960, and the book was published in 1964, actually posthumously. So why this book has become so important to us, or it has given, or it's taken so much credit. Okay, so to know that, I think we will have to little learn about his life, Bharati Krishna Tirthaji's life, and his work, how he was able to create this manuscript in the current era, which we can connect to it so easily and feel math so simple and understandable. So he has, in his manuscript, this is his original work, and in his manuscript, he actually created or listed down 16 formulae. He called it Sutra, and he said these are part of Parishishta of the Atharva Veda. Now, this is what he is calling. We cannot say, or we found it. He said he found it there. So he was born in 1884, and by the age of 15, like anybody else, he did his matriculation in Indian terms. And then by the age of 20, actually, he had done masters in 4 subjects: science, English, philosophy, math. In that, by 1904, from the University of in Rochester University from Bombay. And then by the age of 21, he had joined the nationalist movement. So you can see how, if we are educated and we want to be like part of the freedom movement, he was there. But then by the age of 24, he really wanted to find his inner self, and he joined the Sringeri Mutt. But I think the nationalist movement actually wanted him to be a part of a university, and then they called him, and he started as a head of National College in Rajahmundry. Though he did work in National College Rajahmundry, he went back to the Mutt by the age of 27, and then from there, for around 8 years, he practiced Vedanta. So he left all the college work, nationalist work, movement work, everything, and he practiced Vedanta for 8 years. And by the end of that, at the age of 35, he was initiated to be a sannyasi. After that, he was installed as a Sankracharya of Sharada Peta. And later, by the age of 74, in his last time, he came to Puri as a Sankracharya. During his last time, he was in Govardhan Mutt, Puri. Before that, he was in Sharada Peta. I think that is in Kashmir. I'm not sure. So after he had done these courses on Vedanta and Vedic mathematics, he created this one volume of 16 sutras and an equal number of sub-sutras. And he called that book Vedic Mathematics. But that book was not printed in his lifetime, actually. He passed away in 1960, and in 1965 is when the book was first published. This is a brief history or life story of Bharti Krishna Tirtha Ji. But what are the sutras? The sutras are a small form or okay. The system of the book has 16 sutras and an equal number of sub-sutras. There is a contradiction of how many sub-sutras. Many books say there are 13, many people say there are 16 sub-sutras. But what we are concerned is these short sutras, which are easy to understand, easy to apply, and easy to remember. One argument is that they don't tell what exactly you have to do to solve a problem, but they are not meant to do that. They are generally based on the principle that how the mind naturally works. And then each sutra has many applications. And this explains why Vedic mathematics is so easy to understand and adapt to the current generation. So these are the sub-sutras or upasutras. I listed only some. Many books have given more or, in a different way. So not to take them. Going back to the concept of sutra. Sutra, we all know, or, we have heard. What is a sutra? It's like a thread which holds something in. It's like thread that holds a garland. It can be a garland of flowers or a garland of beads, anything. But the thread that holds the garland is a sutra. And the deepest meaning, it is the deepest meaning that can be conveyed in the shortest form. So there is this very nice poem about sutra, which it says, what is the essence of a sutra, actually. It's, so at the ending, it says, Sutram Vido Viduhu. This is called a sutra. And what are the, characteristics of a sutra? It has minimum alphabets, alpaksharam. It is unambiguous. You have no doubt about it. It is concise. It is universal. It can be applied in many ways. It is universal. And it's non-redundant. It can be applied at any time also. And it has no flaw in it. So this is the meaning or, in gesture, what a sutra should be containing. And if you see Bharti Krishna Tirtha Ji's book, the sutras are like small lines, just, it doesn't go beyond a line. We will do one sutra later. But examples of ancient books which are in the sutra format. Now, Bharti Krishna Tirtha Ji is in the 1900s, right? Before that, who wrote their, theatres in sutra format? Examples are the Sulba Sutras of Bodhayana, Pingala's Chanda Sutra. It's called Chanda Sutra because he also gave his text in the sutra format. Patanjali's Yoga Sutras or Panini's, Vyakarana Sutras. All this, so ancient texts have also been written only in the sutra format, which means that it satisfies this. It's a very short poem or a line, but it still, explains everything which it has to explain, and it is still relevant. So, going back to the sutras of Bharti Krishna Tirtha Ji and what are its characteristics or how, amazing they are. Like for example, we take one sutra, Paravatya Yojayet. So English translation is transpose and adjust. So one sutra can be applied to many things, many problems or many situations. Like Paravatya Yojayet or transpose and adjust can be applied to equations. It can be applied in division, inversion, sequences, tessellations, analytic geometry, and so on. So one sutra can be applied to many cases of solving problems. At the same time, one problem can be, many sutras can be applied to solve one problem. So this is the diversity of Bharti Krishna Tirthaji's book actually. So for example, if you have to solve 45 squared, that is equal to 2025, we can take any sutra and solve it. So that's why we say that, Vedic mathematics is very open-minded. The student can take up which is easier for him or her to solve it. It need not be like only this is the method to solve a problem. It has many ways to solve a problem, or many problems can solve in the same way. So for example, 45 squared is equal to 2025. We can start from Nikhilam Sutra Nikhilam, all from 9 and last from 10, or Yavadunam, or vertically and crosswise, and so on. We can actually apply so many sutras to solve the same problem. So we can solve one problem in so many different ways, or one sutra, one sutra can solve a lot of problems. So this is the diversity of this book, Vedic Mathematics. So I'm sure all of you want to know or see how we apply it, or learn it, or too much talk. So I'm going to take only one sutra today. I'm not going to give you too many sutras, and I'm not going to show any magic here. So if you're ready with your pens and papers, we can start. So what I'm taking is Nikhilam Navatascharamam Dashataha. This is the second sutra, I think, in the list, or the first, I don't know. Yeah. So we are going to use this sutra to solve subtraction and various situations in multiplication. So we are going to do really basic math, arithmetic here. I'm not going to go deeper. But you can see how, once you know one basic, you can keep on increasing and applying to various situations. So if you transliterate this, it goes, the meaning goes all from 9 and last from 10. So this is the formula, or the basic formula. Sorry, all from 9 and last from 10. So we'll have to keep remembering this every time, because this will go across the next half an hour, 45 minutes when we do all the problems now. So ready? Okay, I guess you are. So basically in Vedic mathematics, when it comes to subtraction, we can easily use the sutra all from 9 and last from 10. First, I'm going to start only with base numbers. I'm not going to do sub-base numbers, but remember we talked about base numbers from A to grade, like 1 followed by a number of zeros. So perfect base numbers, they are called perfect base numbers. So to subtract any number from a perfect base number, we use the sutra Nikhilam Navatascharamam Dashataha, or all from 9 and last from 10. Sorry, I just need a water break. Okay.
Yeah.
Okay, let's continue. So now, every sutra, before you start applying it, so every rule has some conditions to follow to follow that rule, like that. So the first part of using this Nikhilam Sutra, the first rule is to subtract any number from a base number, the number of zeros in the base number is equal to the same number of digits being subtracted. So if you are, say, base 10, the number of zeros in 10, so there is only 1 0. So to be subtracted, the number of digits to be subtracted is only 1. So I know 10 minus 8 is 2. We all know that. So we don't need to apply this sutra. We have it in our memory, right? But how about 10,000 minus 9,872? Can we do it mentally without? So this sutra will tell us how easily we can do it mentally. So the number of zeros, 1 followed by so many zeros, and the number of digits being subtracted are the same. This is the first rule to be using this sutra. Okay. So say, for example, 1000 minus 643. The number of zeros here, we see whether it is satisfying the condition which is given to use the sutra. 1000, 3 zeros and 643. Super, yeah, we can use the sutra. Now, what does the sutra say? All from 9 and last from 10. So from left to right, all the digits are subtracted from the 9 and the last digit is subtracted from the 10. Perfect. So when so we laid out 643, this is like a child's play now. And 9 minus 6 is 3, 9 minus 4 is 5, and 10 minus 3 is 7. So simply our answer is very good, 357. You don't feel magic yet, right? So let's try one more. 10,000 minus 562. Again, we'll see whether it's satisfying our condition. 4 zeros here and there are 4 digits. So we can use the sutra. All from 9 and last from 10. So 9 minus 4 is 5. 9 minus 5 is 4. Can I see some answers, please? You can write it in the chat box. How you can actually try to do it mentally, as you know, 9 minus any digit and 10 minus any digit. These are the only two little things you will have to know. A single digit 9 minus any digit, a single digit 10 minus any single digit. That is it. So once we know that, we can give the answer mentally, and that too how we read the solution from left to right. That is another versatility of Bharti Krishna Tripathi Sutra. You can solve the question from a left to right or right to left using the same sutra without any difficulty. So we are actually doing it. 9 minus 4 is 5, 9 minus 5 is 4, 9 minus 3 is 6, and the last from 10, 10 minus 2 is 8. So 10,000 minus 4532 is 5468. Easy? Can we try some?
Yes, Gowri.
Ready? I have 5 questions. There you go. You can write the answers in the chat box one by one. Please don't jump before we say yes, because some of us are a little late to comprehend. Some of us are really fast. So don't give the second answer before we reveal the first answer. So I made sure they're really easy. So you see, the number of zeros here is equal to the number of digits being subtracted. That is a very simple one. So first answer, please. Do this mentally. 9 minus 3, 8, 4. So we are using the formula all from 9 and last from 10. Yes, 3, 8, 4 it is. Second one, 6, 7, 3, 5. Anyone else? Okay. Are you using your pen and paper, or are you trying to do it mentally? That's my next question. Third one. Super. Thank you for that, Vishwajit. Okay. Let's do the answers one by one so the others can also work. You don't give all 5 answers together. Others will be a little disappointed. Yeah, number 4 is 4, 8, 5, 7, 4. And number 5? So I have like 3 or 4 people writing answers. I think I should encourage others to write or say too. Yes. So we pretty much got it. It's so easy, and you can actually directly see the application of this. In our childhood, we used to struggle. You have 100 rupee note, and you spend 37.35 rupees, and then how much is the change you have to get? And we really struggled to do it. If we had known the sutra, I would have easily done it, right? But at the time we didn't even have phones or calculators. Now we have, so we don't struggle anymore. But it would have really been easy to know the sutra, to come up with how much change you will get when you have a perfect one followed by so many digits note. In fact, the sutra can be extended. I am not going extending it, but one more variation. What if the first rule was the number of digits is equal to the number of zeros? Now, what if the number of digits are less than number of zeros? Can we still use the sutra? Okay. Anybody answer? Any answer? If the number of digits is less than number of zeros, can we still use the sutra? Yeah? No? Maybe?
With a slight modification, I guess.
Yes, of course we can. Of course. That is the fun part of it. Actually, for the subtraction from a base, it can go all the way till the actual subtraction of any 2 digits. number, any digit number with any digit number actually. I'm not going till there. I'm going to stop it here with this variation, with little variation. Yes, we should. It is like, yeah, place 0 for the missing digits. Yes, Sarojini, that's what we are going to do. So instead of 64, we are going to take it as 064. This will help us later actually when we do multiplication also. That's why I used this variation. And then we still do all from 9 and last from 10. So 0 from 9 is 9, 9 minus 6 is 3, 9 minus, the last one 10 minus 4 is 6, and that will be our answer. So no problem, we'll still use all from 9 and last from 10. For the missing digits to be equal to the number of zeros, we just use a 0. It doesn't make a difference with the number. So answer for 10,000 minus 36. Anybody wants to put it down? Yeah. Same Swarup, you're missing 1 9. Yeah, 9964. Perfect. So let's do 5 more. I want few more people to answer.
I guess let the ones who are answering at least answer. Yeah. Okay.
Yeah, the excited kids in class. The first row people. Okay. So let's see the answers. Yeah, the first one is 916, number 2. So we are trying to fill in with number of zeros before the number here, so that it matches the number of zeros in the base number here to be subtracted from. Second one.
I think they've already answered second. They've gone off to the third.
9268.
9268. Oh, they've gone to third. So I was thinking, why is it the second answer? Okay. Number 3, Akila has given one answer. Can somebody say, is it correct?
Yes.
949, yes. Okay. Number 4. Take it. Okay. Still working. Okay. Thank you. Yep, 99574 and more. The last one. This can come out from memory. Come on.
Yeah.
Yeah. Perfect. Thank you so much for being such a wonderful audience. So yeah, subtraction from a base. It looks straightforward. All from 9 and last from 10, there is a base number we are subtracting, and it's working fine. But how can we use the sutra in multiplication? I said, like, one sutra has many applications, right? Today we are seeing only one sutra here. So all from 9 and last from 10. And so multiplication, since we are working with a base number or a numbers close to a perfect, I'm talking about only perfect base. We can talk about sub bases if we have more time, but not today. But perfect base, 1 followed by so many zeros. So for base multiplication means what we are talking here, we had given the title to this chapter as base multiplication because we are multiplying numbers near the base or very close to the base. Okay, so near the base or close to the base. For example, if we take the base as 1000, perfect base as 1000, the numbers near the base, say 993, I can see it here, so it's coming in front of my eyes, or multiplied by 984. It's difficult, right? We have to do so many 9s and 8s to multiply. Very simple, he will give. Either close to the base, very near to the base, that are less than the base, both numbers to be multiplied. So if both numbers to be multiplied are very close to one base and they are less than that, or they are more than that. So both numbers are close to the base, but a little more than that. Say 1100 multiplied by 1125 or something like that. Okay. So both numbers multiplied are less than the base or more than the base. That is what we're going to cover today. You can ask me whether one is below and one is above. We can do it, but that involves one more step and one more sutra, which we are not covering today. So I'll take only this. So when both numbers are below the base, I know we know the answer of this, but just for application, I've taken 8 times 6. Both are below the base and close to the base of 10. So base 10 has 1 0 here. We'll have to remember that. So this is our way of thinking math, left hand side and right hand side. Don't think it's complicated. We mathematicians always have proofs and left hand side and right hand side of the problem. So there are two parts of the solution in it. Now, how we can eventually do it mentally, but initially to make you understand how we are doing it, we said we are dividing it into 2 parts, how the solution comes. So for the first part, on the right hand side of the answer is always the number of zeros in the base. So here it is 1 digit only is the right hand side of the answer, and the remaining will go to the left hand side. To understand that, we put that. So how far 8 is from the base 10 is 2, minus 2. Again, how we are getting this minus 2, we need not actually separate. We can use the Nikilam Sutra to get this number, minus 2. And then how far 6 is away from the base 10, it is minus 4. So once we have known that, oh, this is 2 away from base and this is 4 away from the base, we can start giving the solution. The right hand side of your answer is always the product of the deficiencies. Here, this is the deficiency, right? So not thinking this, if you think only these 2 numbers, this is 2 and 4. The right hand side is 8. And the left hand side is simply 8 minus 4 or 6 minus 2. Both will give the same answer. So 8 minus 4 is 4 or 6 minus 2 is 4. Both will give the same answer. So if you see it mentally, we know the answer 48, but this is just for illustration purpose. If you see it mentally, this is 2. So if you want to see, you can mentally say this is 2 and this is 4. And 2 times 4 is 8. That comes to the right hand side of the answer. And 8 minus 4 is 4. So that is our answer. It looks too simple, and we know 8 times 6 is 48. So it doesn't, create much effect for us. But let's go to bigger numbers to base 100. 93 times 98. I'm not going to show you the left hand side and right hand side, but I'm trying to show you how it works. So this is minus 7 less than 100, right? This is minus 2 less than 100. Okay. So our right hand side is minus 7 multiplied by minus 2, that is 14. And the left hand side is 93 minus 2 or 98 minus 7. Both will give the same answer, 91. So this is our answer, 9114. Is it correct? Anybody wants to, prove it? I'll remove it. So, Okay. Did anybody check with your calculators? No?
Vishwajit ji is saying 9614.
9614. Can you recheck?
Can someone recheck and tell?
Because my formula says it's 9114. Yeah? Good?
Vishwajit ji, you rechecked. Yeah, 911.
Okay. Okay. Let's do one more example before I give you your 5 problems to do. Say 98 times 96. Again, if you want to do it without that big checker, like left hand side and right hand side, I can see this is 2 less than 100. This is 4 less than 100. Okay. So I feel 96 minus 2 is easier for me to do. So my first part of the answer is 94, right? Now 4 times 2 is 8. Now remember, my base is 100. So I have to have 2 digits here on my right hand side. So I have to put a 0 there. don't forget, Vedic mathematics never goes or skips the base system of arithmetic or algebra actually. So we don't forget the place value here. So since there are 2 zeros here, we should have 2 digits. Is this correct?
I'm sure it will be right.
So this is the long explanation. We put it up for when we start teaching. It's easier to see it visually for many of us. Thank you, Akila. So now I will let you do it, not me. So I've taken really easy. So don't forget your place value. There are 2 digits right side, and the remaining digits go on the left. Now, maybe for the first few, you will be okay. There is one with a carry digit. When you face a problem, I'm going to say or explain how it comes to the correct answer. I hope you can, take care of the carry digit. Let's see. First one, 8556. Yeah. Second one, you can start working. Okay. Somebody is really fast. Is it correct, JCG? You can cross-check with calculators if you feel doubtful. I'm not saying no calculators are allowed, but for kids, we usually say try to use your brains. Because Vedic mathematics actually works on both sides of the brain, the left side and the right side. It is creative in a sense that, you can use any sutra to solve a problem. Yeah. So yes, 8624. Number 3.
No, that's the first one.
8556, yeah. Okay, is it getting a little difficult, guys? This is 8 and 4. So your right hand side is 8 times 4 is 32, and the left hand side is 92 minus 4. It is 88, correct. And number 4? Yeah, thank you. And the last one. Okay. Are others able to do at least 1 or 2? Please say yes, no, so that I know there are always people who are like very fast in grasping and putting it down. Some people may feel that I'm going fast, but as long as you understand the concept, you can always practice. So I'm trying to be fast because thank you for saying that, Akilaji. Going fast because I want to cover so much as possible with one sutra, so that's why I'm trying to build this up. So, like I said, they are not just magic tricks. They are, physically being proved that these sutras can actually be proved with algebra and geometry. I'm going to show how it is happening here. So it is not a magic trick. It is not like, okay, you remember this and you do this and this is done. There is a basis behind why this works. So this is how we can prove it algebraically that, base multiplication system. So if you take x as 100 in our case, because our example is 98 multiplied by 93, if you take x as 100, what we are actually putting it down, or x minus a and x minus b, because they are close to a base but less than the base, the digits. Let's see. Yeah. So x minus a and x minus b. So x minus a is 98 and x minus b is 93, right? So if you put it that way, if we solve this or expand this a little, we get this formula x into x minus a, something like this. So this AB is the right hand side of a problem. x times x minus b minus a. Now, why x times? Because it's base 100. We are not thinking it's we are putting it down as 91, but it's actually 9100 here, right? So we are just putting the 2 digits. We are not thinking 9100. That's why I said, it place value takes, partial simplicity takes consideration of place value actually. So if you see x minus b minus a, that is the one. So this is already x minus or x minus a, if you say this is a, 98, and then we minus the extra 7 here. So that comes the first part of the answer, 91. So it is actually not skipping any rules of arithmetic or algebra here. It is not a trick or, this is a wand which, I tap and I give you the answer immediately. We are able to answer it because there is a basis of giving that, faster or quicker calculation. So it's basically how the mind naturally works to solve a problem, actually. Thank you. But there is one more, we can actually show it with geometry also. So if you see area of a square, what we want to get is the area here. This is 93 and this is 98. We want to find out this area. But what we are comfortable is the hundreds, right? So what we are doing is we are actually, instead of doing 93, instead of doing it, that we are actually doing 98 times 100 here, the total. So we are getting this area 9800 first, minus 700. So 7 times 100 here. So we are getting this. We are subtracting that. And then we are left with this little, which we shouldn't have subtracted, but we subtracted. So we are adding it back. That is the 14 which we add. So again, the proof can be, the basis of base multiplication is not magic. It has, very, very basic proofs which were, okay. No, I didn't know that. I don't follow Byju's, but thanks for letting me know. Yeah. So that's what we say. It is not really a trick, though, many times they end up saying it's a trick. You just know this trick and you can get to the answer, but it's not really that. The basics of mathematics or algebra or geometry is not skipped in Vedic mathematics. So that is why I said it is not magic. So let's go back to solving problems now. We'll go a little higher, why? Because how, what I would say is, how simple the questions are, when you actually see these numbers and you have to do a long form multiplication with, things like 993 and 998. Many kids, including us, will get really intimidated. Oh my God, so many 9s and 8s to multiply. I'm sorry, I'll take ages to do it. I forgot math after grade 12, things like that. I did forget math after grade 12. I did leave it and I took it back when my kid was in grade 3. But anyway, so we can easily do it again with a base multiplication. Here, the base is 1000. So there are 3 digits on the right hand side. If we take it, 993 is 007 away from 1000. I put the zeros so that, you don't forget your basis or your place value. And this is 002 minus, because both of them are less than the base. 7 times 2 is 14. So I'll have to put a 0 here because I need 3 digits on the right hand side. And then 993 minus 2, 991. Isn't that cool, guys? I mean, it just, the answer comes in just one line. I mean, these steps are really long to make you understand, but if you see it mentally, you can already do it like in a minute. Now, all of us can become Shakuntala Devi, stand on a stage and say, okay, you ask me any digit number, any digit, I'll multiply and tell you in a minute. So that is the, power of Vedic mathematics. Let's practice. Okay, yeah, are you ready to practice? 5 problems with base 1000. I know Vishwajit is super ready, but I want other people also to try do it. So don't forget the place value. I think here you will encounter one. Yeah, 750 times 994. Anybody for the first answer?
Nine eight. Is it?
Yeah.
Okay.
Yes, Anupamali,
Yeah,
that is
yeah.
985.
Nine.
Yeah.
Correct.
Okay. Second one. Cool. Yeah, now you're feeling or you know to place that extra zero because we remember the number of zeros in the base. So that's why we always, it's easier to say you check the number of zeros and that is your the limitation or the rule before following or condition before following the rule. I would like you to do fourth one. We'll skip the third one, but I want somebody to do the fourth one. Put the third answer here already. Anybody? Or should I do it? This is minus 250. Sorry for my handwriting, but it's as bad as it looks actually. So. Minus 250 times 4. So 250 times 4 is actually 1000, right? Oh no, times 6. Sorry. 250 times 6 is 1500. So in our right hand side, we have 1500, but we can take only 3 digits on our right hand side. So this 1000 goes to the fourth place. Okay. And 750 minus 6 is
6 is
744. Okay. But remember, I showed you it is 744,000. So 744 plus 1 is, yes, that's right. You understood now. 744 plus 1 is 745 and 500. So if you read it as 744,000 and there is 1,000 extra here because it's 1,500. So it's 745, 500. That's what, sometimes you find a carry digit. So that is why we say that the base multiplication best works when it is really closer to the base. If it goes away from the base, then we have one step extra and, it might not be so convenient for young children. We can always, mentally think and do the next step and put the answer down. But it's not too, convenient for young children. So at that time, we can pick up some other sutra to do it, but not this actually. But to show you how it really works, any sutra can work in any condition, but it will involve further steps to do it. That's the fun. Last one, anybody wants to put down the answer? It's easy. Yeah? Yeah, thank you. Perfect. So yeah, so close to the base and big numbers, we are able to do it super fun, super fast. But how about above the base? Again, I'll start with base 10, easy one, but nothing really complicated here. Now, instead of minus, we have a plus here. That is the only difference. Earlier, they were close to the base, but less than the base. Now they are close to the base, but above the base. So like 11 times, 12 times 30. Here, this is 2 above the base. This is actually more easier. And here it is 3 above the base. So the right hand side remains the same. 2 times 3 is 6. But the left hand side, instead of subtracting, now we add. So 12 plus 3 is 15. Or 13 plus 2 is 15. So the answer is 156. It is still easy. Now the only difference is instead of subtracting, we add. the cross digits. Everything else remains the same. Let's jump to base 100 because that's more fun when we have bigger numbers actually. So, 108 minus 108. Oh, okay. So the right hand side is, this is easier because we see the plus 8 and plus 8. 8 times 8 is 64. We get the right hand side as 64. And the left hand side, 108 plus 8 is 116. So the answer is 11664. Easy? Yeah, one more example to go before I give you your 5 problems. Do we have enough time or, okay, we still have half an hour. Okay. So 10 times 12, again, it's easy, 120, but remember, we have only 2 digits to go. So the 1 extra will go to the next position. So this is how we actually write the carry digits, and most of us Vedic math practitioners put the carry digit below instead of putting it on top because it goes too far away to remember. So 120, and then if you add 110 plus 12, 122, but there is this 1 here which we added to 122. So that answer comes 12320. So let's go to a practice.
I think I missed that. If the previous slide, can you just explain that again? Sorry, Gowri. Yeah.
So the right hand side has 3 digits instead of 2 when we made the solution, right? 10 times 12 is 120. But we need only 2 digits here because the base is 100. So this one, the 100th position will go to the 100th position here. For whatever answer here, in the 100th position, we'll add it up. So 122 is what we got here. 110 plus 12. So we got 122. But we have one more 100 here. It's actually 12200. You remember when we were discussing the proof, 12200 plus 100. So 123 plus 20. So that is the answer. Okay, ready for some more? Maybe we can do 3 instead of 5, so we can go to the next one. Okay. I'll put down the answers here anyway, so that it's recorded already. Yay, we got the first answer. But is it correct? It's base 100, so there are only 2 digits on the right hand side, not 3. That's the hint I'm telling you for your answer.
That 0 is not there.
Yeah. So the answer is 11526. Yeah, 11526. Are we okay with that? Yeah. Okay, next one. We'll do 1, 2, and 3 only. Yeah. Fastest finger first. 8 times 7 is 56, and there's only 2 digits on the right hand side. 7 plus 8 is 15, so 11556 is the answer. Number 3. Now here you have a carry digit. Perfect, actually. Thank you, guys. Yeah, 15450. Here, 50 times 3 is 150. So you have 1 to carry. And 150 plus 3 is 153, but we already carried 1, so it becomes 15450. Now you can see I'm actually mentally doing, I'm not a master, I teach, but then I don't memorize and practice. So I also work along with you guys. So I'm really blunt in saying that. But as you see that, it is so easy to do it mentally once you know the sutra. Actually, you within a few times, you will actually do it really mentally and work on it. Initially, yes, you need a pen and paper, so don't hesitate to take them out. It's not a sin to take a paper and pen or use your fingers to do mathematics. But yeah, with these sutras, you can really work faster mentally. So that is why, it has become, or the term of magic math and things like that had come up in the, current generation Vedic math teachers. Instead of saying Vedic mathematics, they say fast math and, memory math and things like that. Everything is basically Vedic mathematics given by Bhakti Krishna Tirtha actually. Base 1000, again, above the base. I don't think we need to do it. It's the same thing. So I'm just going to show you that it works actually. Even if you go above, much above, it actually works. As long as, the rules are, or the conditions are, both numbers are the same base here. What if it is a different base? Yes, you can do it, but not now. For the first basic thing, we'll have to understand that what we are doing is both numbers are near the base and both numbers are near the same base. That is when this sutra works initially. Of course, you can make a little adjustments. Like what I said, what if the number of zeros is not equal to the number of, digits, then then we add a zero before, right? Of course, we can work around, but that comes later. For the first, to understand the sutra, the first condition is both are the same base, and then both are close, and both are either above or both are either below the base. And it is the same base, not a different base. So here both are really close to 1000. Okay, so that's how it works. So I'm not going to go through this, though I did put it down, but I think we'll skip this part and go to the next section. We are still using the Nikhilam Sutra actually. We are still using the concept of all from 9 and last from 10, but how we are applying in different situations is what we are seeing here. Now, I just put 2-digit numbers, but it can go more. But we'll limit to this only because it's easier to grasp and understand, and it's easier to show. Close to, but less than 100. Now we are actually, we said first of all we are saying two numbers being multiplied same base, both are below the base. So obviously the next logical thing you can think is, then if it is one number I want to, which is close and less, and then I want to square it. Basically two numbers, right? Say 93 square is basically 93 times 93, right? So we can still use the Nikhilam Sutra to do it. And actually in a shorter way, because we have only one digit here to remember 7. This is 7 short. So our right hand side is basically the square of the deficiency. What is deficient here is 7. So right hand side is just the square of 7, which is 49. How we are getting it? We are getting it using the Nikhilam subtraction. 100 minus 93 is 7 actually. That is why it is called Nikhilam multiplication. And the left hand side is just subtract the deficiency from the number. So 93 minus 7 is 86. So our answer is 8646. So it is like one step less than the previous one actually. It goes much faster. So now let's see a 98 square. Anybody to give the answer? So the deficiency is 2. So mentally, if you think 98 minus 2 is 96, and 2 square is 4, we need 2 digits, 04. Perfect, Prince. Thank you so much. Yeah. So give such a big explanation, but you see, you have done it before I do the number of clicks here. One more. 89 square. Here the deficiency is 11. So 11 times 11 is actually 121. So you remember it has one digit more. So you have a carry digit here. Yeah. So we have such a big explanation, but you see, you actually give the answer much quicker than the number of clicks I do on my computer here to show you how it works. Let's do 5 problems, 5 squaring problems now. $92 square. Yeah, it's 8464. Second one, I think, did somebody give the answer already? Yeah, 7744. Number 3. Right. So basically what you're thinking mentally is this is 6 short of 100. So 94 minus 6 is the first part of answer. It is 80. 8 and 6 times 6 is 36. So 8836, that's your answer. So it's actually as fast as that. So number 4 is 9216 and number 5 is 7569. Perfect. Thank you so much. You all are actually going as fast as I click one click on the computer to show the answer. And believe me, with a little practice, you can go much faster than that. So how about more than 100? It's still the same. Now instead of subtracting, we are just adding, right? So 103 square. So we'll write 103 plus 3. So 106 and 3 square is 9. Again, remember this is base 100. So we have 2 digits. So the answer comes to 10609. That's as fast as that. Can we try some? 1, 2, 3. Number 1, number 2, number 3. So the first one itself is like has a carry. Did anybody give the answer yet? 112 plus 12 is 124 and 144 there is a carry here. 125, 44. Number 2. So it is, yeah, 11025. And number 3, the last one. I'm sorry. Yes. Okay, I'll put down the answers for the next 2. Let's not work it, but there is more, guys. Actually, we said squaring now. Now I'm going to give squaring was 1 step shorter, definitely in Nikilam. So what about I have only 9s? This magic trick is so easy, and I'm saying magic. I'm sorry, I shouldn't have. But this is one step more shorter, and you have a series of 9s to multiply with any digit number. Now we are not close to 100 or not close to 1,000. The second number is any number, but the first number is with a series of 9. Suppose I have to multiply 999. My only condition is give me a 3-digit number. I'll multiply by 999 and give you the answer in less than a second. Okay. How we are doing that? We are still using the Nikilam Sutra actually. And it's so easy and fast. I am not going to show a magic wand here. Actually, I'm going to show you how it is done. So any 3-digit number by 999. Okay. So as soon as you see this, if you see your right hand side is only -1, one short, right? And here you can easily apply the Nikilam Sutra to get all from 9 and last from 10 from this number, right? So instead of 567, with all from 9 and last from 10, we have 433, right? And then this actually becomes the right hand part of the answer. And for the left hand part of the answer, we just do -1. 567 minus 1 is 566. So this is our answer to this long big multiplication. So you apply all from 9 and last from 10 for the right hand side of the answer. And for the left hand side of the answer, you just take away 1 because there is only 1 here, -1, 567 minus 1. Still using the Nikilam Sutra here, but there is one more sutra called Ekanu Nena Purvena by 1 less than 1 before. Okay. Actually, it's just to describe that, this can work easily, or, it's much faster than before, right? So let's try one more. I mean, I'm not going to show you the explanation, but, look at the number of 9s here to multiply. It's scarily easy. All you have to do is actually, you read these numbers. So you're answering. So we are trying to be Shakuntala Devi here, all of us. You're answering. So you see the numbers 867967 multiplied by 999999. Okay, good. So I'll start giving the answer. You see whether the answer is right. So my answer is 867966 1320033. Am I correct? Yeah. So that's how it goes, but actually we're just applying the sutra here. So on the right hand side, we apply all from 9 and last from 10. That's what I read it out, 1320033. And the right hand side is one less than this number, 867967. That's as easy as that, actually. So the only condition here is the number of digits is equal to the number of nines. Again, you will ask, what if the number of digits is not equal to the number of nines? Can we still do it? If the number of digits is less than number of nines, we can do it now itself. That's why, we did the first part, subtraction by simply putting a 0 to match with the number of nines. Say, for example, 56 and 999. So the first part is the same, one less. So the first part is 55. But for the second part, we need 3 digits here. So we just put a 0 here. And then we'll say 944 is the second part. So 55944 is the answer. Okay, so this also we can do. Actually, there is one more step to it, which I'm not covering now because you will need to know, vinculum numbers or negative numbers to do it. But it can still be done. Multiplication by 9 and 11 are the favorite parts of Vedic mathematics. So we'll do some, just to know that we have a magic wand in our hand and we learned a lot of, super cool stuff today. Yeah. First answer, 36 times 99, or 36 multiplied by 99. Again, you're seeing big numbers here. You're not doing the long form multiplications, 3 steps, 4 steps, 5 steps, nothing. Everything comes in one line. Everything, can be done mentally, and the answer can be given left to right. Not like answering right to left and reading left to right. No. 3564, yes. Number 2. Now this should come really fast, guys. Nine nine six zero three three. Number 3. Yeah, because the number of digits is not equal to the number of nines here, so we added a 0. So it comes to 975, 24975. Okay. So I'm going to show you the answers. Yeah, it looks like a magic now. Right? So this is where I end my magic show. So initially I said, no, Vedic mathematics is not magic. It does have proof, it does have basis. That is true, really. But when we actually solve it, we see that, magically answers come, and mentally we know that it's actually not magic and it has proof behind it. Or we can actually, the principles of mathematics are not skipped here to find out these, solutions. So this is one sutra we tackled only in subtraction and multiplication. Mekhilam Sutra has like more applications in division and algebra and so on and so on. But since it's just an introductory thought, I thought, I'll just, use one sutra and try to show you different applications. So that's where I end. So I end with this shloka. Why I choose this shloka again has a unique thing to it. Vedas had always been very cryptic. superfluously they look like mantras, superfluously they look like, just some chants. But of course, when we read Upanishads, we know there is a lot of meaning to it. Concept of infinity, perfectly, yes. The Purnam here is actually during the Vedic times. So this is from Isha Upanishad. We all know that too, because we chant it at the end of all our things. So the Purnam, or the concept of infinity, has been like, we had attributed Purna as the Brahman, right? But then the term infinity, or the mathematical connection to it, there are many places in the Vedas where they use the term infinity in different forms. Like it's called Ananta, Samkheta. Asamkheta is like, there is no Sankhya attached to it. So Asankheta. So the infinity, I mean, we spoke about zero at the beginning of our talk, but even infinity is so much layered inside the Vedas, right? So this one is from Isha Upanishad, and it says like infinity is there, which is full. But then, if you put a mathematical sign to it, okay? If you take away infinity from infinity, it is still infinity. And if you add that, it is still infinity. So that is the Brahman. But, even mathematically, we can prove this sloka as, Purnam, or complete, or infinite. So thank you, guys. I know I took a long time. I tried to, compress so many things in the same hour, or 1.5 hours. But let me know your thoughts, comments, and how do you feel about it. I'll end.
We congratulate and thank you both for your knowledge, for your really it is we could learn last phase. We could learn something. So it's you are versatile. I thank you. I bless you.
Thank you so much.
So maybe if there might be questions, a few questions. In case there are, can we ask them to send it to, maybe everyone has my email ID or WhatsApp number. Please do send it. I'll pass it on to Gowri. She will answer it personally, and we'll make sure you get the answer, just because we're going to run out of time. But yeah.
Definitely.
Anyone wants to say anything, please do quickly. Sushmita, you can take over.
Thank you so much, ma'am, for such a lively and wonderful session indeed. Mathematics is infinite, like you said, and so we have to keep learning quite a lot more. 1.5 hour or maybe 1 hour session is absolutely not enough. Maybe we could have few more sessions to understand more about Vedic mathematics. It was quite interesting to learn so much. So I think
very nice. Thank you, Gowri. Really thanks.
Thank you all. Yeah, go ahead. Sorry.
Yeah, sorry. So I think we are going to nurture the next Shakuntala Devi and Ramanujans in future. So, yes. Anyone else would want to say anything, or we can have a vote of thanks? No?
Yeah, that's fine. I think you can.
Okay, so thank you so much, ma'am, and thank you all the participants for putting in so much of interest and all your keen participation here. We will now end with our ending prayers. Over to Sindhura and Haima, who will present us with the ending prayers. Haima? Sindhura is not there. Haima, you can take over.
No, we both are here, Didi.
Okay, yes, thank you.
ॐ स्वस्तिर्प्रजाभ्यां परिपालयन्तां न्यायेन मार्गेण महिं महिषा गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं शोभरहितः ब्राह्मणाः सन्तु निर्भयाः सर्वेषां स्वस्तिर्भवतु सर्वेषां शान्तिर्भवतु सर्वेषां पूर्णं भवतु सर्वेषां मङ्गलं भवतु सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः हरि ओम श्री गुरुभ्यो नमः हरि ओम